do we unlock infinite time travel, right? How can a user go back at point in time and just update the snapshot at that point in time? How do we get to the non-blocking concurrency control? And we have an answer. Again, if you look at the problem from database perspective, LSM trees, we simulated 1 million commits, which is proportional to like every commits every 5 minutes for 10 years. And it took about 367 milliseconds to load the whole timeline without all the metadata. Why do we have partitions in data lake? Well, data lake partitioning is really an old Hadoop era band-aid, right? I'll show the functional index in action here. So we created a table. It's partitioned by city. There is a timestamp field here called TS. In the query, I've highlighted the predicates. There is a partition predicate, and then there is a predicate on the function of TS column, R of TS column, right? Let's look at the plans. The left one is the one without the index, and the right figure is with the index. If you look at the number of partitions read, that's 2 in both cases. But the number of files read and the size of the files read, it's reduced by half. And why is that? Because files that qualify this criteria, our TS greater than 12, are just 3. And without the index, you're not really able to skip that. More importantly, it is not just for order preserving function. Remember, here our is not an order preserving function. So we think that this is going to be very game changing for Lakehouse. So current merge on read merges the records based on keys. Can we do better? What if we record the positions, if we encode the record positions and just log the changed columns, then we'll see that we can skip certain data pages, right? And this will vastly improve the performance when you have update heavy workloads. Not only that, it also provides first-class support for partial updates. The APIs that are being written, being done in a manner so that they are engine agnostic with partial updates. In this benchmark, what we have is the schema had 100 fields. Again, it's 1 TB merge on read table, similar setup as before. Schema is 100 fields, but we are updating only 3 fields, right? Look at that, at those gains, both on the write as well as the read path. There is reduced write amplification, there is reduced read amplification. We have built Spanner's true time like API, and the global monotonically increasing timestamps kind of reflect the serialization. Each commit is marked with a completion time and end time. And when the compaction runs, the file slicing algorithm will ensure that the log files are tagged to the correct base files. If you look at the screenshot here, for each commit, you have the start time and the completion time, right? And if you look more closely, you'll see that the one delta commit and the compaction commit that I have encircled here, they are running concurrently. This is the first time you'll see two concurrent streaming writers, and there will be no block-in.